Okay, everybody, we're gonna start a new chapter right now, and chapter 2. And I was listening to my videos from chapter 1, and my voice sounded like that teacher from the famous movie from 1980s, Ferris Bueller Day Off, where he was taking role and he was just so monotone that all the students were falling asleep. I sounded like Ferris. So I hope I didn't put you to sleep, and I will try not to do that in these videos. Anyways, chapter 2 is on on relations, functions, and graphs. And as usual, I'm not going to cover every single topic in this chapter. I'm just going to hit the most basic ones. So we're going to start with section 2-2 and 2-3. I'm going to combine those two. In the last chapter, we talked about a linear function that we usually write it like this, and we call it linear because when you graph it, it produces a straight line, and the highest exponent or the degree is 1 here. So anytime your function has a degree of 1, then its graph will be a straight line. Now, this is one form of writing a linear equation. More famously, we call it slope-intercept form. And the reason we call it slope-intercept form is because m, the coefficient in front of your variable, is your slope, and b, this constant here, is your y-intercept. We're going to get into those a little bit later. The other form that we talk about is this form, which is called the standard form. I hope everybody can read my beautiful handwriting, which we don't see that often, but sometimes you will see it. And the last one is this, which is called point slope form. So these three forms of writing linear equations. Now the last one, we usually use it to put the equation either in standard form or in slope-intercept form. So it is, we usually don't put the final equation in this form, but we do use it. Okay, so we have different ways of graphing these kind of equations. One way is using the intercept form or intercept method. And what does that mean? Well, in order to graph any straight line, you need a minimum of 2 points. So if you get the x and y intercepts, then you have 2 points. You can just connect them and draw the graph. Now, what do we mean by x and y intercept? Now, before we do that, we have to talk about the coordinate plane or the Cartesian plane, which I'm sure everybody knows about it, which was, as the legend goes, originally used by famous 17th century French mathematician and philosopher René Descartes. The first time I heard his name, or saw his name, I pronounced it Descartes, but I didn't know. I don't speak any French, but I found out later that it's Descartes. But anyways, the point of intersection of these two straight lines is called the origin. This is the horizontal axis. This is the vertical axis. We usually label the horizontal axis by x and the vertical axis by y. Not always, but a lot of time. These spaces that are formed are called quadrants. For you guys that are Trekkie like me, who like Star Trek, they use the phrase quadrant, quadrants in the galaxy a lot. So anyways, these are called quadrants, and we usually label them with the Roman numeral going counterclockwise. So this is Roman numeral 1, so that's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And if you go to the right of the origin on the x-axis, they're positive values. To the left is negative. If you go up positive, you go down negative. Basically, these are all two number lines that are intersecting at a point, and they're perpendicular to each other. So let's say I have a graph, a straight line that goes like this, where it intersects the x-axis. That's called the x-intercept. So this is called the x-intercept. And where it crosses the y-axis, we call it the y-intercept. Now, and remember, when you are on the x-axis, you have no y values. There is no movement going up and down. So your y value is always 0, but you have some kind of an x value. So whenever we talk about the y-intercept, it's always, whenever we talk about the x-intercept, the y value is always 0. And I hope everybody remembers writing a point as a ordered pair, x and a y. We always put the x value of the point first and the y value of the point second. That's why we call it ordered pair, because there's an order, x first, then y. And then for the y-intercept, if you're on the y-axis, there is never an x value. So the x value is always 0, and you have some kind of a y value, whatever it is. So the intercept method for graphing a straight line is always using the x and y intercept. So if you know these 2 points, then you can graph it. So let me give you an example. Let's say you have this equation, y equals to, I'm just making that up, 3x minus 2. And you want to graph it by the intercept method. Okay, so the easiest way to do it is to make a little table and find the x and y intercept. Now, in order to find the x-intercept, we know that the y value will be 0. So you put a 0 in place of y. So you know that your y value is 0. So if I put a 0 in place of y, I get this. I'm going to solve for x. So I get 2 equals to 3x and divide by 3. So x turns out to be 2/3. Not the best value to graph, but nonetheless. Now if I want to find, so that's my x-intercept. Now if I want to find my y-intercept, I put a 0 for x. So that means my x is 0. So I will get y equals to 3 times 0 minus 2. So what's 3 times 0? Anything times 0 is 0. So that's gone. So your y value is -2. So here we go. There is your y-intercept. So I'm going to graph it now. Graph the first one. It's on the x-axis. If this is 1 2/3, I'm estimating 2/3 is close to it. That's right there. And then the y-intercept, you got 0 and -2, so you go -2 units on the y-axis. There is your y-intercept. So then you just connect them, and voila. I can't draw a straight line, but imagine it to be a straight line. So there is the graph of this equation, of this linear equation, y equals 3x minus 2. So that's one way of doing it. The other way of graphing a linear function is using the slope and the y-intercept. So before we do that, we got to remember, what does it mean by slope? Slope is the definition, well, first of all, what's the symbol for slope? Slope, the symbol of it is always lowercase m in algebra, not capital M, because capital M is used for midpoint. So please make sure if you're using the symbol, it has to be a lowercase m. And from middle school, we remember slope as defined as rise over run, or the change in the vertical direction, that's rise, over the change in the horizontal direction, that's run. The formula is y2 minus y1 over x2 minus x1. I hope you guys remember that one. So, for example, if let's say I give you 2 points, this is an example. Let's say I give you 0 and 2 and 4 and 1. And I say both of these points are on the same line. Calculate the slope. So how do I calculate the slope? So let's call this point 1, let's call this point 2. Or other way around. It doesn't make any difference because both points are on the same line. So if this is 0.1, this is x value, and this is y value of 0.1. This is x value, and this is the y value of 0.2. So you just plug it in. y2 minus y1. So 1 minus 2. 1 minus 2. x2 minus x1, 4 minus 0. So you get negative 1 over 4. So there's your slope for the line that passes through these 2 points. So if I were to graph these 2 points, 0 and 2, that happens to be a y-intercept, 2, 3, 4, and 1, then if I can draw a straight line, hey, I did it almost. No luck. That would be the graph of the line that passes through those 2 points, and the slope of it is negative 1/4. So that's how you calculate the slope. Okay, now if you have a positive slope, your line is always rising if you look at it from left to right. If you have a negative slope, like the last example, and you saw it in the graph, the line will be falling from left to right, as we call it. If the slope is 0, you always have a horizontal line, always. If the slope is undefined, then the line is always vertical. Okay, so remember those. Okay, and we also have to remember 2 more things. The equation of a horizontal line is always y equals to a number. The equation of a horizontal line is always y equals to a number. And the equation of a vertical line is always x equals to a number. So, for example, if I give you y equals to negative 2, and I say graph it. So that will be, you go to the y-axis, you locate negative 2, and you draw a horizontal line. And there you go. And that's a graph of that equation, y equals negative 2. And the slope of that line, you don't even have to calculate it. If it's a horizontal line, boom, it's automatically 0. The slope is 0. The line is not 0. The slope of the that horizontal line is always 0. Let's say I give you x equals to 3, and I say graph it. So you go to the x-axis, you locate 3, and you draw a vertical line. And that's the graph of the equation x equals to 3. And the slope of that line, of this line, is always undefined. It's always undefined. And the reason it's undefined is that in a vertical line, what is the definition of slope? Change in the y direction over change in the x direction, right? If I look at this line, I'm just going up and down, right? So there is a change in the y direction, but the line is not moving. I mean, nothing moves this way horizontally. So there is no change in the x direction. So when I plug this in here, the denominator will become a 0 because there is no change. And remember, if you have a fraction that its denominator is 0, then automatically the fraction becomes undefined. You cannot divide by 0. That's why the slope of a vertical line is always undefined. Okay. Now, talking about the slope before we go any further, if you have 2 lines that are perpendicular to each other, I hope you remember your geometry. This is the symbol for a 90-degree angle. Remember, if 2 lines are perpendicular, that means they intersect, and at the point of intersection, a 90-degree angle is formed. So if you have 2 lines that are perpendicular, their slopes are negative reciprocals of each other. So let's say this is line 1, this is line 2. So slope of line 1 would be the negative reciprocal of slope of line 2. What does that mean? For example, if line 1 is perpendicular to line 2 and slope of line 1, let's say, is 3, then the slope of line 2 will be negative. That means you switch the sign. If this is positive, it will become negative, and you flip it over 1/3. because this is 3 over 1. So that's the slope of line 2. Another example, if a slope of line 1 was negative 2/3, then the slope of line 2, if the lines are perpendicular to each other, then it's the opposite in sign, so that means this is positive, and you flip it. So it's 3 over 2. So this is the relationship between slopes of perpendicular lines. They're negative reciprocals of each other. If you have two parallel lines, again from geometry, L1, L2, parallel lines are lines that never intersect, then their slopes are always exactly the same. Slope of line 1 will equal to slope of line 2. So please make sure you remember that as well. Okay, so let's go back to our earlier example that I gave you, y equals to 3x minus 2. And let's dissect it. So if you compare it to y equals mx plus b, what is my m? My slope, is the coefficient in front of your x, in front of your variable. The variable is never part of the slope. So that's 3. Is that a positive slope? Yes. So you know your line is going to be rising. So if you get some other graph, like falling line or vertical or horizontal, you know you have a boo-boo. And then what is your y-intercept? Your y-intercept is b, this constant here. So your y-intercept is negative 2. I'm going to write it as an ordered pair, as a point. Remember, y-intercept, x is always 0. So there you go. So how do we graph it knowing these two quantities? You start with your y-intercept, 0 and negative 2. And then if I say this is 3 over 1, then the rise is 3, the run is 1. So always, from your y-intercept, you do the rise. So how many units? If it's positive, you go up. So 1, 2, 3. 1 space, 2 space, 3 space. And then 1 unit to the right. Rise over run. So there you go. So we got the same line as our previous example. You see? Same line. Except we use the slope and the y-intercept instead of the y-intercept and the x-intercept. And the x-intercept we had originally was there. Okay? Let me give you one more example. Let's say we have an equation that looks like this. Y equals to negative 1/4 plus 1. Oh, sorry, x. So what's your slope? Slope is negative 1/4, and your y-intercept is 0 and 1. Now notice the slope is negative, so that means you have a line that is falling. You already know that. So you start with your y-intercept, 0 and 1. What's your rise? Negative 1. Okay, so you can take the rise to be negative, or you can take the run to be negative. Not both of them when you have a negative slope. So we usually take the rise. So negative 1. So from the y-intercept, you go down 1 unit because it's negative. And then what's your run? Positive 4. So you go to the right. So 1, 2, 3, 4. Voila. There is your second point. And we know the line is falling because the slope is negative. I cannot draw. So there you go. That's the graph. So this is graphing a linear equation using slope intercept. Using the slope intercept form. Woo, talking too much. Okay, we're gonna go for a few more minutes. So I'm going to do some examples, and let's see. The first example, the first two examples are word problems from page 174. Now I'm going to read it. This is problem number 76. Problem number 76. It says, after purchasing an autographed baseball card for $85, so the card was $85, its value increased by $1.50 a year, $1.50 per year. So there are two parts to the problem. What is the card's value 7 years after the purchase? So let's do that part first, part A. So before we do part A, you got to write an equation. So let's say value, define your variables. So word problems, we always define our variables. Let's say for value of the card, we call it V. And then time, we call it T. And we usually use lowercase t. Capital T is usually used for temperature. Okay, so can we write a linear, and this is a linear relationship, so we can say value equals to $1.50 times T plus the original cost, which is 85. So there is your linear relationship. We don't always use X and Y. All right, let's see. So it's part A. It says, what is the card's value 7 years after the purchase? So part A, what is the value 7 years? So this is time in years. So I'm going to just put 7 over here and then use my beloved calculator. So $1.50 times 7 plus 85. So the value after 7 years will be $95.50. So that's part A. Part B, it's asking you how many years will it take for this card's value to reach $100? How many years will it take for the card's value to reach $100? So now we have the value, we want to find the time. So the value is $100. What's the time? T. So we solve for T. So subtract 85 from both sides. Cancels. So you get 15 equals to 1.5 T. And since 1.5 and T are being multiplied, you divide by 1.5. And voila, you get 10 years. So in 10 years, the value will be $100. And don't forget your units. The units for part A was dollars. Unit for part B was years. All right, let's try number 80. Problem number 80. Where is it? Now I'm going to read that. For the years 1990 to 2000, the percentage of the U.S. adult population who were smokers can be approximated by the equation. So they give you the equation y equals negative 0.52x plus 28.7. This is how many adults were smoker between 1990 and 2000, where y represents the percentage of smokers as a whole number, percentage of smokers, and x equals to 0 represents 1990. So x is time. So if you put 0 over there, that means you have 1990. If you put 5 over there, that means you have 1995. If you put 10 over there, that means you have 2000. Use the equation to find A, the percentage of adults who smoked in the year 2005. So part A, we want to find out what is y if x is in 2005. So that will be 15, right? Because x equals to 0 corresponds to 1990. Okay, so you put 15, so y equals negative 0.52 times 15 plus 28.7. So we have negative 0.52 times 15 plus 28.7, and that gives you 20.9%. Remember, y is in percent, but in the problem says y represents the percentage of smoker as whole number, so you gotta round this sucker up to 21%. So in the year 2005, it was 21% according to this model. Part B, the percentage of smokers is projected to fall below 15%. So now you have the y value. It's very similar to the other problem. And you want to find X. So I'm not gonna finish this, you guys can finish it. Subtract 28 point, well, let's just do it. So 15 minus 28.7, you get negative 13.7 equals negative 0.52x, and then divide both sides by negative 0.52, and you get x to be 26.4 approximately, and that's in years. Okay, so but it says what year. So the final answer is not 26 point. So if you add 26.4 to 1990, what would that be? And that will give you the year 2016. So 2016 would have been a year that, according to this model, the number, the percentage of adult smokers would have fallen below 15%. Okay, I'm going to stop right here, and then we're going to continue in the next video.